So, why did you all moan, or some of you moan when I wrote volume on the screen? Have you done? Who's done it before? You've done volume before? Okay. So far this year we've talked about distance, which is one-dimensional. It's just a length from here to here, and it might be 1 foot or 1 inch or 1 centimeter or 1 mile, whatever it is. It's in units like that. You understand why it's one-dimensional? Okay, this segment, all it has is length, correct? That's all it has. One dimension, length, that's it. Can we pick it up? Can you grab it? No. Can't, can you? Even if you try this direction, you can't get it, can you? Okay, it's because it's one-dimensional. Then we talked about area. Now, area is two-dimensional. So if we talk about, for example, the area of a rectangle, or the area of a circle, or the area of a triangle, we don't measure them in feet or inches or centimeters or miles. How do we measure them? How do we measure area? In squares, right. We measure it in squares. So we block it off and we measure it in squares. So we might have, in this case, we have 8 square feet, for example, or 8 square centimeters, or whatever units we happen to be talking about. And it's two-dimensional. It has length and it has width. And even a circle has 2 dimensions, doesn't it? 2 directions on it. Same thing with the triangle and all that. Thank you. Okay. Again, we can't pick them up, can we? You can't grab something that's two-dimensional, can you? Okay? But now when we talk about volume, now we're into the three-dimensional phase. So, there. 3 dimensions. Now we have a width, we have a length, but we also have a depth. So you can see all 3 of those dimensions, can't you? And can I pick it up? Right. I can get a hold of it, can't I? That's a 3-dimensional object. So one thing we got to be clear about is I'm going to be drawing objects like a cube, and I'm going to draw them so that they look 3-dimensional. But is it? No. No, this one's not 3-dimensional, is it? It's drawn to look that way, but it's not really 3-dimensional. And when we measure the volume of something, we're going to talk about not its number of feet long it is, or how many square feet it takes to fill it up. We're going to talk about what? What are we going to talk about? What?
Surface area.
Ooh, yeah. We're going to, if we're talking about volume, we're going to talk about the number of cubes that it takes to fill it up. Okay, so this would be 1 cubic foot. It would be 1 foot by 1 foot by 1 foot. So those are its 3 dimensions. Now, I think I had one here a minute ago. Where did my cubic foot go?
Oh, I took it.
It would be hard to lose. So here I have a cubic foot. You guys might call it a box, right? But there you go, cubic foot. Its dimensions are 1 foot by 1 foot by 1 foot. It's 3-dimensional. Okay, so it has width, right? It has height, and it has depth. So we have those 3 dimensions. So this is a cubic foot. This, that's not a cubic foot. What is this thing? Yeah, it's a cubic inch. And I used to have a bunch of little cubic centimeters too. I'll have to get some of those and we'll talk about those. So this is a cubic inch. It just depends on what we're measuring, that would depend what kind of units we're going to use. So, for example, if I were the heating cooling guy and I had to put a heating and cooling system in a house, the first thing I need to know about that house is how many cubic feet of air it takes to fill that house up. Because I've got to heat or cool all of that air. And so I need to know how much of it there is. So in this room, for example, I could figure out how many cubic feet, okay, we have in this room. So let's do it. Ready? So we're going to figure out the volume of our room. So I'll draw it for us here. I think our room looks something like this. You guys happy with that? Does that look okay? There's Mr. Collard's room. Okay. Let's find out our dimensions here. So we need to know the height of our room.
26.
8 feet. 8 feet tall. It's not exactly 8 feet, it's like 7 feet 10. But we're going to pretend like it's exactly 8 feet to make our life easier. Okay? And then we need to know how wide our room is. Let's see, that's 15 right there. I don't think my tape is long enough to do the whole thing. Okay, that's 8, so we know 23. So we got 23 feet wide, and then we need to know the length of our room. Here, Matt, hold that against the back wall. Okay, this is 17, so 18 right to the front of the desk. Okay, let go. All right, Katie, hold it right there. 11. So 18 and 11? 29. So we're 29 feet that direction. And to find the volume, to figure out how many of these it would take to fill up our entire room, what we do is we multiply those three dimensions. We multiply 8 times 23 feet wide times 29 feet long, and we end up with 5,336. But we don't just do that. Feet times feet times feet. How many feet? What type of feet? Cubic feet, right. So when we take feet times feet times feet, it's just like 3 times 3 times 3 is 3 cubed, isn't it? Well, feet times feet times feet is cubic feet. So that's a lot of cubic feet. Were you surprised it was that big of a number? 5,336 of those boxes right there to fill up our entire room. Do you want to do cubic inches?
Let's be like Billy. That would be a lot.
It would be a lot, wouldn't it? We could actually figure it out though, because we can change from cubic feet to cubic inches. Guess how many unit multipliers it takes?
3.
Good guess. Who said 3? Nice work. Good job. 3 of them. Because we've got to have feet down here 3 times, don't we? And what needs to be on top? Inches. So that way we get our cubic feet to cancel, and inches times inches times inches is? It's cubic inches. I know when we write it, we write inches cubed, but we don't say it that way. We say cubic inches, which is kind of tough because sometimes when I say 7 cubic inches, I think people envision this, 7 cubic inches. But when I say 7 cubic inches, is the 7 cubed or is the inches cubed? Yeah, it's this way. So we say it backwards from the way we write it. And that's just the way it is, and you just got to get used to it. Okay? So that's just the way it is. So if we're gonna do our conversion, we're just going to take that number right there, and we're going to go times 12 times 12 times 12.
That's a lot.
2 million.
9,220,608 cubic inches. That's a few. That's a few of those.
We should like
Ugh. Could we change that to cubic centimeters?
go through the whole entire room.
Ooh.
That'd be like over.
That would be a lot, wouldn't it? You'd have to take that number, and then you'd have to multiply it by 2.54 times 2.54 times 2.54. Ooh. Now we're up to, let me see, comma, about 1.5 billion?
That's nothing.
That's a couple. Okay. So, one thing I wanted you guys to notice is finding the volume of something is actually pretty easy. Okay, if it's just a rectangular solid, like if I have a swimming pool like this, and it's 3 meters deep and 50 meters long, 50, and 25 meters wide, we can find the volume simply by multiplying those dimensions together. So we can take 3 times 50 times 25, and we end up with 3,750. And what about meters times meters times meters? Cubic meters. Okay? Now a cubic meter, think about that. Do we have a meter stick? I have a meter stick. Okay, so here's our cubic foot. Now a cubic meter is going to be a box that's that wide and that deep and that tall. Right? That's a pretty good sized box, isn't it? I think I could get Gracie and Cadence in the box. Do you think I could stuff those two into that? That's a pretty good sized box, right? Didn't we talk about this the other day?
Yeah, you probably could.
And if we killed them, we could probably get the other Gracie in too. You can pack them tighter. Yeah. Okay. We talked about cubic yards. Oh, where'd my yardstick go? Oh, there it is. What did I order that was in cubic yards, guys? Concrete. That's right. So I got the concrete. And, you know, I went back home and I looked at it, and I had figured 2.5. Well, we figured 2.25, and then I was going to get 2.5. But then I looked at it more carefully, and I noticed that there were some places that were deeper than 4 inches. And I noticed along the edge where it meets the garage, I dug a trench there that I forgot about because I wanted the concrete deep right there. And make it a little thicker, make it a little stronger. And so I thought about it some more, and I decided I was going to get more than 2.5. And I actually got 3. But I would have only gotten 2 3/4, but they charge you for 3 even if you don't get 3. So if I only get 2, they charge you for 3 because they have to drive the truck to your house and everything. So if you only order 1 cubic yard, they're going to charge you for 3 because they have the time and everything. So it's called a light load fee. So I was like, well, I'm getting 3 anyway, so it didn't really matter. So I got 3, and guess how much it used?
All of it.
2 3/4, I would say. 2 3/4, it used that up, and then the rest of it was kind of left over.
Where'd you put the rest?
I had another driveway next to it, and I wanted to I don't know if you guys can see that. So that's rebar that I have every 18 inches or so in there, so that it's in there. And then over here to the left, you can't really see, I have a little smaller driveway, and I just kind of dug it out, and then the leftover concrete I just poured in there and just kind of spread it out so it was, I don't know, an inch or so thick, and just it basically just turns into gravel when I run on it and stuff. So sometimes you get something else ready so that you can make like a little walkway or something like that. But if you look at this little sidewalk piece right there, I had about enough to do one of those, is what I had left over. So yeah, volume. So volume's pretty easy. I want you to notice something. This 50 times 25, this is what we call the area of the base of the figure. That's the area of that rectangle on the bottom, and then the 3 is the height. And a lot of times with volume, this is the way we express it. We say it's the area of the base times the height. And let me show you why we think of it that way. If I have a different type of figure, let's say I have this triangular prism right here. Okay, first of all, we have to think about what is the base of this triangular prism. Is it, right now, the way I've drawn it, is it resting on the base? Is the base on the bottom, would you say? Some yes, some no. Okay, the base is actually these triangles on the ends. See the triangles on the ends? Those are the bases, and it doesn't really have a top and a bottom. They're both bases. They both work. Okay, so those are the bases, and then this right here would be the height. Maybe I can describe it better if I talk about a can of pop. Maybe you guys understand a can of pop a little bit better. So can you guys see the bases here?
Yeah, the 2 circles.
Yeah, the circles on the top of the wall. Well, what if I tip the can over?
Still the circles.
Okay, it's still the circle here, right here. All we have to do is figure out the area of that base and times by the height of the figure, area of the base times the height of the figure, and that will give us the volume. And it will work all the time. So let's say this is 6 inches by 5 inches by 10 inches. Can we find the area of this base, guys? Half, right?
Yeah.
6 inches times 5 inches. It's half of 6 times 5? 15. 15, what kind of inches? Yeah, square inches. It's the area of the base, right? That's squares. Times the height, 150. And what's square inches times inches? Cubic inches, and that's the volume. Okay, that's our volume. We don't worry about that so much when we look at a rectangular solid. We just multiply the 3 dimensions together, but it's still area of the base times height, however you look at it. Okay. Now, our circular cylinder here. Let me draw it again. Our cannel pop. It's got a radius up here of, what do you guys think, 3 centimeters maybe? And maybe it's 20 centimeters tall. Is that enough information to find the volume?
Yeah.
Okay. So we can find the volume. All we've got to do is take the area of the base, and this gets confusing because I'm circling the top, but I'm saying area of the base. Is this the base? Yes. Is this the base? Yes. Okay. All of these figures, we don't worry about the top and the bottom. The bases, they're the same thing. So what is the area of the base? What? I heard 9. 9 times what? Pi. And what type of centimeters? Square centimeters. That's right. That's the area of the base. Times the height
Which would be 20.
times 20 centimeters. Now look, if you take 20 times 9 times pi, it's okay to times the 20 and the 9 before you times by the pi. You don't have to times by pi first. It's timesing. You can do it in whatever order you like. It's commutative. Times pi, and square centimeters times centimeters?
Cubic centimeters.
Cubic centimeters. There's the volume of the figure. That's all we have to do. Area of the base times the height. And that will give us the volume every time. You'll notice, if you look at the very, very back of the book where it has all those formulas for you. Want to find it? Can you find the one that looks like our circular cylinder in the very back there? Crazy. Very back of the book there. Volume. The volume, it says pi r squared times h. So I want you guys to notice the first thing is pi is a number. So they put it first. R and H are variables, they go second. So pi r squared, that was we did that, didn't we? Times H, that's the height. There, you got it. Now, when we write our answer, we don't put the pi in front. We put the 180 in front, and then we put the pi second. Because we're using that symbol like it's, even though it's a number, we're using it like it's a variable, so it comes second. So there it is. You can use that formula, you can do this, but area of the base times the height is going to work out for any type of right figure. Now, it won't work. Look at the one right below the circular cylinder. See the pyramid? It won't work for that. See the circular cone? Won't work for that. See at the very bottom of the page, the basketball? Won't work for that. But see the one right above the basketball? See that? That weird shape with the circle on the left and then kind of the two rectangles put together? That's the base, and then it has a height. It will work for that. So I want you guys to turn to page 88. This is a picture looking straight down at the top of the figure, at the base. These are right angles. And then, can you guys all see the three-dimensional picture of it? See that? Tyler, you with me?
Yeah.
We can see the three-dimensional picture, can't we? This is as if you were up above looking straight down at it. That's what you would see. Okay? If we can figure out the area of this thing and times by the height of the figure, which is always given to you in the paragraph, okay, then we can get the volume. Now, I think you guys know how to find the area of this figure. We've done this, haven't we? Okay? We can split it into a rectangle and a triangle. Can we find the area of the rectangle? I better tell you what units we're in. Meters. What's the area of the rectangle?
6 times 4.
Okay, 6 times 4, 24 square meters. What about the triangle? How long is the base of our triangle here?
36 by 6.
Okay, so the base is 6?
Yeah.
Because this part's 4 and they have to add up to 10, right? See it?
Even though that 4 looks bigger.
Yeah, even though my 4 looks bigger, sorry. So, what is the area of our triangle then?
36. Right?
Wait a minute. How's it start?
Oh, wait. Yeah, you're right.
How's the area of a triangle start? Oh,
So it'd be-
half.
I'm pretty sure.
I'm pretty sure you're right. Half of 6 is 3 times 3, that's 18. Or you could go 36 and then take half later, couldn't you?
Yeah, that's fine.
Yeah, that's still fine. So we have 24 and 18. And if we add those two together, 30, 42? 42 square meters. That's the area of the base. Okay? And then what we do is we multiply by the height of the figure. Now everyone read the paragraph on the top of page 88 with me. See that? A base of a right prism 8 meters high. Do you see where you're going to find the height of these all the time? Okay, so this is 8 meters tall. So we take the area of the base, we multiply it by the height. That's 16, carry the 1, 32, 33. Square meters times meters?
Meters.
Cubic meters. And that's the volume, area of the base times the height. Now you guys, you already know how to find the area of the base, don't you? So timesing by the height is not a big deal. You're just taking something you already know how to do and just multiplying by the height, and there you have your volume. By the way, 336 cubic meters. That's a lot. That's a lot of space, isn't it? Yeah. If I were going to buy carpet for this room, would I care about its volume?
No.
All I care about is what? The area of the floor, right? Okay. But when we talk about the size of a room, there's more to the size of a room than just the area of the floor, isn't there? Okay. So if I build a house and I build a big great room, and it's 24 by 24 feet, and the ceiling is 6 feet tall, this tall, is that room going to feel like a very big room?
No.
No. But wouldn't you have the same amount of space to move around in it?
Yeah.
Your head would hit the wall.
I'd have to crouch just a little bit, but I'd be able to walk around. I'd have the same amount of room in there, really. Right? What if I made the ceiling 8 feet tall like this one?
That just seems bigger.
Would it feel bigger?
Yeah.
What if I made the ceiling 9 feet 6 inches tall?
That would be pretty big.
Would it feel like a taller room? It would feel bigger. But would I have really any more room to move around in it? Not unless I was like wanted to run and jump, right? That would help. But just kind of walking around, it wouldn't really make any difference, would it? Okay. Would it make a difference when the heating cooling guys came to put the system in the house? It would, wouldn't it? It would take a bigger system because it would be more air that has to be heated or cooled, and it has to move it in and out. So these things are rated. You feel it blowing? That's probably why you're freezing cold.
Yeah.
I have the vent on, so the vent blows all the time. A little bit. It blows harder if the heater comes on or the cooler comes on. But what they need to know is how much time it takes for this thing to suck all the air. See those vents in the back by the port? The air gets sucked into there, and it goes through the heating cooling system and through a filter, and then it gets heated up or cooled, and then it gets blown through the ceiling and then back through these. So we need to know how long that takes, how many cubic feet per minute. That's called a CFM. We need to know how long it takes to move all the air in this whole room through the heating cooling unit and then back into the room. And it has to be able to do it in a certain amount of time. Or it's not powerful enough to do it, or you're spending too much money because you're getting a system that's too big for no reason. And most of the time, I don't need a lot of heating in this room. I put 30 of you in this room, and you have a tendency to heat it up. You know, like today, even though it's cold outside, by noon, I'll have to turn the air conditioner on.
Should turn it on.
Because you guys come in here and all your little bodies are 98.6 degrees, and you keep inhaling the air and blowing it out 98.6 degrees, you keep heating all my air up. You stop breathing so much, and then our room will stay nice and cool. Or if you want it to heat up, you just have to breathe more.
With these masks, it will keep it up close.
Okay, now, look over on page 89. Example 20.5. Look at that shape. Does that look pretty bad? Finding the area of the base. Look at the base. It's like a triangle with a half circle cut out of it and then another half circle added onto it. That's horrible. Example 20.5. We haven't talked about finding the area of something like that. But look what it says on the inside of it. 52 what? It's telling you the area of the base. And it's also telling you the height in the paragraph. Find it in the paragraph. 15. 52 times 15, that would be cubic feet. That would be the volume. So if it tells you the area of the base, that's all you got to do is take the area of the base and times by the height. Turn over to page 90. Look at practice C. What's the area of the base? 50 square centimeters. What's the height? 12 centimeters. Can you find the volume? You can do this. Okay. We're doing set 20. Let's get it done before the end of class. No homework tonight or anything. Let's go. Get after it.